Hi, ma'am. Before class gets started, I just wanted to say I'm really sorry, but I left my webcam at my grandpa's house, so I can't use my camera today. But I am.
Okay. All right. Thank you very much for letting me. My mic is. Thanks a lot for letting me know.
Hey, Professor.
Yes.
I got a couple questions on the assignment 0 that we had to do.
Yeah.
Are we So I was just confused on number 1.
Okay. Any Moodle question you ask me at the end of the hour, I can stay with you.
Okay, not now. All right.
Yeah, I stay with you as much as needed, and I work with you on the Moodle. If you have any questions, yes, I will definitely help you with it. But at the end of the hour, what?
Oh, all right. At the end, got it.
Yeah. Does it work with you? Does it
Yeah,
work for you? Sorry. Okay.
Yeah, man.
Great. Yeah, definitely. No issue. No issue with that.
All
Good morning, everybody. Good morning, Clea. Questions about the practice problem. How did you guys do? And please put your questions on chat. I insist practice problem are important. Okay, I can read them. Very good. All right. So we're gonna go through your practice problem, and you guys, of course, you should know that I graded your quiz. Every time I grade, I put a lot of comments, as much as I can, of course. So please read them. If you don't read the comments, you're not gonna learn anything. All right, so please read the comments, and if you have questions about them, you didn't understand them, you let me know. The quiz, the only problem that you guys had difficulties with in this quiz is basically problem number 1. 2 and 3, as a whole, it wasn't bad. Some student has issue, but they have to talk to me about it or see the solution. But number 1, a lot of you had issues, and a lot of you lost their points right there. So I will just go over it again, because we have to understand, what is the function doing. So let A be the set of all women, all possible women. And F is the function that to each woman assign the number of children she has given birth to who are alive on January 15, 2020. Okay, so what is F doing? So if I'm going to think of F as a machine, what do you give F? What will F spits out for you? Okay, if we read the question, F is assigned to each woman. So there are a lot of women. So the input changes. I mean, you have half of the population kind of is a woman. So there are lots of stuff in the domain. So assign the number of children. So it is assigned to each woman. So there is an assignment, the number of children. So if you think of a function as the machine, what do you give the function? And what the function should give you? Okay. Before we answer those questions here, what do you give it? It is signed. So what's going to be the input?
A woman?
The woman, because to each woman, it is signed. So you input the name of a woman, like Michelle Obama. We input her name, so we input the woman. What will F do to this? What will a machine gonna spit out in this case?
The name?
No. Read the problem.
Oh, the number of children she's given birth to?
Right. It spits out the number of children. Crucial to understand this function. This is like a rule. You give it the woman, but the woman, it changes. Of course, there are tons of them. To every woman, the number of children is going to change with the woman. So you input the woman, it output the number of children. Okay, so I hope all of you know Hillary Clinton. I think you do, of course. Suppose the woman is Hillary Clinton. What is F of Hillary Clinton? You guys know, I hope. So what am I asking for? When I
the
put
number
F,
of kids she has.
Right, how many kids Hillary Clinton has? Do you guys know? Don't worry, she has only one child. I mean, one daughter, Chelsea. That's really what this idea is about. Okay, so your input is the name of the woman, which changes, not one. When your output is how many children this woman has. Okay, so I picked Michelle Obama because, I don't know what else because I think all of us know her. So F of Michelle, Michelle Obama is a woman. F of Michelle is, quickly, how many
Two.
children Michelle Obama has?
2.
2. That's really the output. So as the woman change, of course, there are lots of women. To every woman, we are going to assign a different number, which the number is how many children she has. That's how you understand the function. Think of it as a machine. You give it something, it has to spit out. And you have to read what are you given and what it's going to spit out. So now I go back to my question. F of C. So C, what type of object is? I'm not going to give away the answer. So is F of C in this problem an output or an input? Question number 1. Look at the picture.
Inputs. So it's the input.
No. F of C is what? Is it here or here? Left or right?
Left.
Up. No. F of C. It means what, if you input C, what does F associate to C? That's the F of C.
Ah.
Okay, C is your input. What's between parentheses is the input. And F of C is what you assign to C. So in this problem, what do you assign to C? So let us say C is Hillary. What did we assign to her? Number of children. C is Michelle Obama. What did we assign to her? The number of children. I have 2 boys myself. So F of Norma Elias is how many children I have, which is 2. And so on. So F of C is an output. So what type of object is F of C? Is it a number? Is it a person? What type of object? Back to you. Look at the picture.
A number?
Absolutely, because it's the number of children. So F of C is the number of children that woman C has. So C is a symbol for any woman, because when you give you a function, we cannot always recite every possible input, because the input here is every possible woman on earth. So we use a symbol C for the woman, and F of C is the number of children that woman C gave birth to.
So
It's a symbol.
C is the input, right?
What?
C would be the input.
C would be the input. And in my picture, the input is what? A person, a number. That's what I mean.
Okay. Person.
Yeah, it's in general, it's actually more of a woman because whatever, it's a woman. Okay,
Oh, because I didn't word it right on my quiz and you marked it wrong, I guess.
doesn't matter. I mean, the idea is for you guys to learn. So F of C represents the number of children. Now, if F of C equal D, what type of object is C? So now what am I asking for? C in this question is an input or an output value? Right, but it's between the F is inside. So this C represent what in my problem? It's a symbol for what? A person or a number?
Person?
Person. It's person. In this case, it's a woman. So it's a symbol. It's the output. It's this piece. It's right there. Symbol for a woman. Okay? Because when you give a function, the input take all kind of values. As the input changes, the output will change. But so we use the symbols because we cannot say, okay, F of this person equal this, F of that equal that. It's impossible. So we use symbol. We say what F does to a typical. In general, what F does. So here, F of C, as C is a woman, is the number of children that woman C gave birth to. So this is the output, which is the number, and this will be the input, which is the woman. Okay, so try to think about it a little bit more, and that's where you guys had issues in this quiz. The rest as a whole went fine. I did correct the mistake. Some of you had problem with fraction. Please either come to me or review them, because we have to get through this hiccup here. Okay. Now I go back to your question, and now Leah has one of your classmates has issues. So I will start with 1.7 and then I will back up to she have 1.6. Okay, so let's look at 1.7. Please do the practice problem. So when you come, you're ready. Okay, 1.7. Okay, and 5DFH. Wow, a lot of the 5s. Okay, so number 5. And I start with D, whatever D is. D, okay, very good. So we have the following function, f of x. So that's a rule. It's a machine. You give it something called x. It's gonna spit out what you give it square plus 7x plus 1. Okay, and the question, so I'm doing D. And the question is, find all values of t such that f of t is 19. Okay, so that's really my question here. So I have this rule. Remember, it's a rule. The machine is a rule.
Real quick, I'm sorry, it's negative 19. F of t will equal negative 19.
Not in my book, though.
Yes, and also the formula is different.
Yeah, it's not. In my book, it's 19.
Oh, are you doing, no, that's C.
I don't know what I'm doing.
5D is the one that's negative 19. That's the
is
one
it-
that I was asking about.
Oh, okay. All right, I'm gonna waste one page. I'll go to D. My apology, I didn't pay attention. It's the same stuff. It's the same problem. So we're not gonna make it, it doesn't matter which one I pick. It's minus x squared, sorry for that, plus 4x and plus 2. And my question is, find all value of w. So the book is giving you different letter names just to that you use, such that g takes w to minus 19. Okay. So again, this is this machine called the G, and you give it anything, you give it an input, but the input changes. Keep in mind. So x is a symbol for a number. That's what x is. And it spits out whatever you give it square plus 4x plus 2. Another question is, we want to find the w such that g of w is minus 19. Now again, this minus 19, is it an input value or an output value? Quickly, I want
Output.
answers. What? What did you say? Repeat.
That's the output, right?
Yeah, it's absolutely an output value because the question is, I want minus 19. It's an output value. And the question, what should I put inside the machine so it will spit out minus 19? So it's an absolutely an output value. It's not an input value. Input, they would have asked you what's a g of minus 19. If that's the question, it's a 19, but that's not what the question is. All right, so how do we solve that? What do we do? Quickly. We want to find, what should I put here to get minus 19? So it means we're gonna set minus w squared plus 4w plus t equal minus 19 and solve for w. It's crucial. Any questions about this setup? Any questions? All right, so how are we gonna solve for that? Remember, how do we solve for that?
We make
Okay,
it to equal 0, right?
Right, we have to make one side equal to 0. One side equal to 0, period. So what do you want me to do? Please hurry up, we have a lot to talk about. Start what?
So you add 19 to both sides?
Add 19.
Wow.
Yes, this will make one side to be 0. And then this will give me minus the w squared plus 4w. And when I bring this here, I add, I will get 2 plus 19. This will give me plus 21. Correct? Now, I can imagine why your classmate had difficulties is. I think she had difficulties because you have the minus here. Okay, so how are we going to solve that?
Are you asking me or are you asking the whole class?
I'm asking the whole class.
Oh,
I'm not answering. I think I have to start asking specific student.
Do you have to factor out a negative?
Yeah, this will make it easier. So one way, because this minus to bother, we can say multiply by -1 across. Okay. So if I multiply this by -1, just to make it a little bit easy for us. And if I multiply this by -1, nothing changes. But this will make it a little bit easy, so I don't have to deal with negative. Minus minus is a w squared minus 4w minus 21. And now this problem is become much easier, so I don't have to worry about the minus, but I had to multiply both sides by minus. Now what do we do at this stage? Quickly. And please turn on your camera, except those who can't.
Factor.
Now factor. Okay, what are the factors? So I want two numbers. You multiply them, you get 21. You add them, you get 4. What?
X minus 7.
It's
X plus
okay.
3.
7
Or W minus 7. W
That's
plus 3.
minus. How can the product be 0? If this is 0, what value of W will make this 0? Every W that makes 1 minus 7 equal to 0 will make the whole thing 0. And every W that make that 0 will make the whole thing 0. So this will give me W equals 7. And this would give me W equal minus 3. And of the problem. Okay. And graphically, what are we doing here? Graphically, my function g of x is this one. Is minus x squared plus 4x plus 2. That's my function. That's my output. If I graph it, it means I do the following. I put all the x value here, the y value. I make a table, and I pick several values of x. And I compute the output for them. And I sketch those points. I will get a graph, which is very soon you guys will know how to do it very easily. And I will get something like that. That's the graph I will get. And so the question is to find all the points where the output, so what shall I put here to have an output of minus 19? So basically here the question is the following. Minus 19 is an output value. That's minus 19. And the question, okay, what are those inputs that are giving me minus 19? That's really what my question is. And according to us, this should be, so my output is minus 19, and that's the input, that should be a 7. And right here, the output is minus 19, and the input that corresponded to it is minus 3. So that's really graphically what we are looking for. All right, so let us go through other ones, but please, I want all of you to, I want all your input. So I look at, I did D. Okay, I look at F. Okay, number F. What was it? We have the following function. G of x equal x over x squared minus 3x plus 3. So that's my function. And the question is, find or value of W such that G of W equal to 1. So it's again like before. I want the input that gives me an output of 1. So what do I need to solve? I need to find the W, such that G of W plus 3 equal to 1. This 1 here is an output, and I want the input that goes to it. All right, now so solve this for W. Okay, question now back to you. How do you want me to solve it?
You multiply by the bottom of the fraction to the other side.
Absolutely. This one, denominator bothers me. It should bother you as well. So what we can do, we're going to multiply both sides by this denominator. And really the benefit is really to be able to work with it, because it's kind of hard to work with it. So I will have W over this. And then I'm going to multiply it by this denominator so I can get rid of it, basically. It's equal to 1 times W squared minus 3W plus 3. The goal is, if I multiply, this is gone. And then I will be left with this. 1 is 1. And the problem should be much easier. Equal to 3. Now I need to solve that. Okay. How do you want me to solve it? And since you guys are quiet, I'm going to pick one of you. And remember, when I pick a student, I usually forget who
I have a quick question.
Yes.
In the beginning steps where it first gives us the rule, when it says find W and you have the 1 circled, what does it say above that?
Output.
I'm sorry, I'm just trying to take notes.
Oh, no problem. Absolutely no question. No problem. You guys ask any questions under the sun you want, kind of. Got it? Okay. Now, what do you want me to do? Okay. Can I factor out? Can I factor out? No. What should I do first? In words. I don't factor out. I have W here. What should I do first?
Subtract the W.
Right. I have to make one side is 0. So we don't factor till we make one side is 0. So we're going to subtract W. That's why I want you to work with me, because I want you to do mistakes. Then we learn. That's how we learn. Now I'm ready. So this is W squared. If I subtract this minus W, I will be safe. I have a 0 and then minus 3 minus 4W plus 3. Now the problem is actually easy. Once I put, so I'm going to rewrite it this way just because we're used to that. Now I can factor. You factor after you make it equal to 0. Okay. Now is the factors easy in this problem? I need two numbers. When you multiply them, you get a 3. Add them 4. I mean, you don't have lots of choices here. Only 1 and 3 would do. And it should be minus equal to 0. So now if this happens, it means we have W minus 1 equal to 0, giving W equal to 1. W equal to 3. Okay. How do
I
you
have a question.
Yes.
Why would it be both negative again? Besides 1 negative, 1 positive? Yeah.
Here, because you have minus for W.
Okay.
If you had a plus, what will happen?
It'll change.
Yeah, because multiply them out. Those should be the same. If I had a plus, I will have W times W, it's W squared.
Okay.
Plus 3W, plus W. I will not get the same thing.
Okay.
I'm not changing the expression. I am rewriting it so I can solve it. Crucial.
Thank you.
Okay. Now, how do you check that what you're doing is correct? Back to you.
You
You
plug it in
Plug it in into
the expression.
of the function. So my function was x over x squared plus 3x plus 3. I plug it in. I'm going to plug one of them. I want to plug 3, for example. If I get 1, I'm doing correct. If I don't get 1, it means, sorry, that's minus. I'm doing wrong. What's g of 3? 3 from here. It's a 9. Minus 9 plus 3. I simplify them. I get a 1. Okay. You can do the same for G1. We're checking now. We're not solving. Now we're only checking our work. Right. So let's see which one I will still do, but then I have to start. H. Let me look at it. Okay. I'll do H and then H. Again, it's the same ideas. So really we're doing the same ideas here. F of x is 2 plus the square root of x plus 4. And the question is, sorry, I don't think I wrote it correctly. Minus 6 plus the square root of x plus 4. And the question is, find all j such that the function takes j to negative 2. So again, it's the same approach. Means I want to ask myself, what should I put here? So the output will be negative 2. So I'm going to set that equal negative 2 and solve for x. I mean for j. Okay. Now I go back to you and ask you the question. What do you want me to do? Let me pick one of you, if you don't mind. Cameron Boyd, what would you do if you were doing this problem? Are you with me? I think you are. What would you do? Cameron, are you with me? Okay. Cindy, are you with me?
Yes.
Okay. What do you think I should do? Remember, I don't care about the wrong answer.
Add 2.
Because add 2. What will be the benefit of doing this?
You get everything on one side.
We get what on one side? If I add 2, okay, I get them on the one side, but will this help me? If I add 2, I will get minus 4 plus that. Then what do you want me to do after this?
Add 4 to both sides.
Add 4 to the both sides. Now it's better. And now?
Get rid of the square root.
By?
You would square the 4.
Absolutely. Absolutely. Yeah, that's one way to do it. Or instead of adding 2, what will be another way to do it? So what you want is to isolate the square root term, right? That's really what you want. So how else can I do it?
You could have started with adding 6 to the negative 2.
What?
You could have started with adding 6 instead.
Right, adding 6. Add 6, not multiply, because it's minus 6 plus that. So I need to add 6 from both sides. Okay, I can do it the way you did. It's absolutely fine, but I think this is easier. Add 6 to both sides. Because I want to isolate that, so I need to add 6, because this is not multiplied by 6. So we add, we get this equal minus 2 add 6 plus 6, which will save the day, is equal to 4. Now, it's definitely what you had here. It's slightly in a different format. Now we square them. This will give me the j plus 4, and we're almost done. Equal 16, which will give me j equal subtract 4 away, j equal 12. Yeah. All right. Okay. Now I know that there are 2 questions that I think I answered most of them. So if there is anyone else, I will take care of it next time, or you guys start to work on it after we did that. So if you have any other questions, do it again and see if you guys can get it. All right. Today we are going, there's going to be actually a very easy section. It's not hard. So 1.7 and no, 1.8, 1.9. Okay. So it's 1.9 is easy. It's about decreasing and increasing functions. But before to do that, we have to remind you a little bit of interval notation. So first, okay, I'm gonna recall that the symbol, this symbol means less or equal. Less or equal. So 2 less or equal to 4. Okay, basic stuff. And this one means greater or equal. So 4 greater or equal to 2. Okay. Now interval notation. So we're going to talk about interval notation. Okay. First, let us say I want to describe all, so I have a number line here, and I have, for example, 2 here, and I want to describe everything less than 2. Okay, everything less than 2. So we have an interval notation for it. What's the interval notation? Okay, the following. Watch carefully. We can put minus infinity 2. That's an interval. This represents all values of x. So when I write this represents all values such that x is less or equal to 2. Okay, so for example, 1 is in this interval, minus 3 in this interval, 4 is not in this interval. So this means everything less than 2. Everything you see right there. Now, we use this following notation. 2 infinity. You don't have to put plus anymore, it's just infinity. We put minus infinity when we're having everything less than 2. So this represents, so in interval, this is my 2, everything here. That's really what I want. So this represents all values of x such that x is bigger or equal to 2. Okay. Now, suppose I want to follow, I have the following interval, and I want to tell you all possible number between 2 and 4. I want to describe this. All possible number, okay, between 2 and 4. Okay. We use the following notation. Bracket close 2, 4, comma 4. Okay, so when I write, you see this interval notation, what do you mean? It means all values of x such that x is bigger than 2 and x is less than 4. Okay, so this means everything larger than 2 and less than 4. Now, this x larger than 2 and smaller than 4, we can combine this into one double inequality. So another way, but we write it usually, is all values of x such that, how can we combine this? Such that the x is less than 4 and bigger than 2. So we combine this by writing x between 2 and 4. Be very careful with those signs. There is tremendous, a lot of times students mess up this. So this read that 2 is less than x, which makes sense. 2 is less than x, and x bigger than 4. So that's the notation for that. Now, the other interval notation that you guys will see is sometimes you see something like that, minus infinity plus infinity. This means every possible number you can imagine. So this is your number line, every possible number. 1/2, minus a half, square root of 2, everything. So this represents all values of x, all possible numbers. Okay. So this is some interval notation that we're gonna use in this section, and anytime we actually feel the need for it. Okay, any questions about that? Okay, now we're gonna define what's an increasing function and a decreasing function. Remember, function is a rule that you give it input and it associates an output. The input changes. As the input change, because the input is not one value, there are a lot of values. The input change, your output will change with it. And believe me, calculus is about change, about how the output changes with the input, which is, we're gonna do a little bit of that in following section 1.10. So what does it mean for a function to be increasing? Very, very simple definition. So let f be a function. It means always imagine you have this rule, you give it an input, spits out an output. We say that f is increasing on an interval. So f increasing if whenever the values of t, it means my input value increases, so the value gets larger, the value of f of t, which are the output, will increase as well. It means as your input gets larger, your output gets larger as well. So that's what an increasing function. We say that it is decreasing if whenever the value of t increases, it means whenever your input value increases, the value of f of t means your output values will actually get smaller. That's what decreases mean. So as your input increases, then your output actually loses value. That's what decreases is. So immediately, what's the impact on the graph of an increasing and decreasing function? How does it look exactly?
Would increasing be going up to the right?
It has to be up to the right because
The numbers are getting larger.
right, because when the input, so increasing. That's graphic. Remember, on the horizontal is always your input, crucial. And here, the output value. So suppose this is my interval I'm interested in, and I'm describing f increasing now. This is not what I'm interested in, then what's happening? I mean, as your classmate said, the function rises because suppose at this point, this is the output. So let me call this -2. The input increased. As we move to the right, my input increases. If it's increasing, it means the output at -1 should be larger. So my output at -1 has to be larger than my output here. That's as simple as that. At 0, 0 is bigger than -1. So my input is still increasing. My output will have to get larger. And it gets larger, and it gets larger, and get larger. So if I connect dots, my graph has to basically rises as you move to the right. So if f is increasing, it means that the graph rises as we move to the right. Always we move to the right because we always make the input increase and we see what happened to the output. Always we let our input increase and see, okay, what's happening to the output? It's definitely increasing as we move from left to right. Now, how is decreasing? Again, so again, this is -2. -1, 0, 1, 2, 3. Okay. So this is my interval from -2 to 3. And as I said before, suppose at -2, this is the output. It's decreasing. It means as your input gets larger, your output getting smaller. So at -1, that's the output. Remember, the output is this vertical distance. At 0, I don't know, suppose it's 0, right there. At 1, it has to be less. So I'm going to go down. At 2, it has to be even less. At 3, it has to be even less. So when I connect the dot, it doesn't have to be a straight line. I'm going to have something like that. My output is getting less and less and less every time. So here, F decreasing means that the graph falls as we go from left to right. From left to right. Okay, so graphically, that's the picture. Increase, that's my output getting larger, and this is my output getting smaller and smaller and smaller. Okay. All right. I'm going to give you a lot of examples. My first two examples are word problems, which are fairly simple. I mean, nothing really. I'm not even pretending that what the questions are hard by any stretch of the imagination. But let me see what you have to say. So let's read a simple problem. Okay, a hot cup of coffee, like what I have on my table now, is put on a table. Okay, and let F be the function that is signed to each time the temperature of the coffee at the time t. Now t equal to 0 corresponds when the coffee was put on the table. So that's when I start measuring the temperature. I put my coffee on the table, start measuring the temperature. T, the time measured in minute, the temperature in degrees Fahrenheit. Okay, so question number 1 is the following. What's the input in this problem? And what's the output in this problem? What do you bring in? What do you take out? Okay, I'm gonna pick one student. Okay, let's see. I don't know. Jared, are you with me? Are you with me, Jared? Okay. Jessica, are you with me?
Yes.
Go ahead.
Sorry, I was trying to write down the practice problem.
Okay, I'll give you a minute to write it down. I mean, 30 seconds. Okay. Whenever you're ready, let me know, okay?
Okay.
Read it.
When,
2. So what do you give it? What should it give you?
should it be that T is the temperature of the coffee? So would it be the output?
Uh-huh. What's the input?
The coffee?
What do you mean by coffee? Let's read it. It is
Okay.
signed to each time the temperature. What does F do? So you put a cup of coffee here on the table, okay? And F does what? So every time it gives me the temperature at time, okay? So to every time t, it gives me the temperature. So what do you input for it? What do you give it? And what does it spits out? You give it the time. Okay, like 1 minute after I put it under, 2 minutes, and F gives you the time t, and it's gonna give you the temperature at time t. Okay, so The temperature of the coffee is changing with time, right? So the F does what? F, you give it time, it gives you the temperature. So it assigns to the time. So you give it the time, but assigns to it. So that's the machine. The machine gives you the temperature of the coffee. So the input here, what's going to be? Is it time or temperature? If you're comfortable, answer, or I pick another student. I don't really care, basically. So what's the input here?
It would be the time.
Time, because that's what you're going to give it. And what's the output here?
The temperature.
The temperature. Okay, so you give it time, it spits out the temperature. All right, so suppose, so if I ask you the following question, all right, what's the unit of f of t? Very symbolic question. What's the unit of f of t? What would f of t represent? If I put f of t, the t inside would represent what?
The amount of time.
What f of t would represent what? What will be the output?
Temperature.
What?
Temperature in Fahrenheit.
Temperature at time t. It will represent the temperature at time t. So that's really, so ft is time. F of t, temperature at time t. Where t is the amount of time after I put the coffee on the table. So before I even ask you anything, again, I want to make sure you understand the function. Suppose I tell you interpret, which is something I always do. Interpret, I'm working with the same problem. F of 5 equal 90. Interpret this. What kind of info I am giving you here? Who would like to answer?
So is that saying that after 5 minutes, the coffee is 90 degrees?
Right. It means that's the input. So that's the time. It means 5 minutes after I put the cup of coffee on the table, the temperature is 90. So this is the output. So that's 90 degrees, and this is minute. So in English, it means 5 minutes. After we put the coffee on the table, the temperature, that's the output, is 90 degrees Fahrenheit. Okay. So that's really what the function. So you give it the time, that's my machine. You give it time, it gives you the temperature. You give it time, it gives you the temperature. Now, if I tell you, if I take, for example, f of 10, is f of 10 going to be more than 90 or less than 90? You know, time is changing. I have my coffee here. Is f of 10 bigger than 90 or less than 90?
Less than.
Less. Do you agree with him? Because?
It's a decreasing function.
Because. The answer is simple. I'm not pretending it's a hard question. Because the coffee is doing what now? It's cooling off, right? You have the hot cup of coffee, you put it, it means the cooling off. So after 10 minutes, the temperature is definitely going to be less than 90 degrees. After 5 minutes, it's 90. After 10 minutes, it's going to be less than 90. So the temperature is changing, and it's actually less than 90. So my last question concerning the same problem is the following. Your classmate did answer, but I will ask again. Sketch the graph of f and decide if it's increasing or decreasing. So make a rough sketch of the function. Make a rough sketch. A rough sketch of f and decide if F is increasing or decreasing. Or decreasing. Okay. Rough sketch is we're going to have two axes and we do our best. Question number 1. What should go on the horizontal axis in this problem? Leah? Leah, are you with me? I think.
Yes.
Yeah.
The time?
Right. What goes always on the horizontal axis? The input. My input here is time in minutes. What goes on the vertical axis always? The output, temperature in degree Fahrenheit. Now make a rough sketch. Of course, I don't have a lot of values. You know, I gave you the only thing I gave you at 5. I don't have a lot of values to sketch a graph. That's why I was very clear. Make a rough sketch of the function. So at 0, it means when I put the coffee, let us say the temperature 100. Now as time change, as time increases, what's going to happen to the graph? The temperature, I don't have numbers, I don't really care. I didn't ask you to do that, but we want the idea. The temperature is going to decrease, decrease, decrease. Okay? Eventually, it will get close to the temperature in the room, whatever the temperature in the room is, but the function is going to decrease. As time goes by, what happens is that it's going to cool off. Cooling off meaning the temperature is decreasing because F decrease simply because the temperature, because the coffee cools off. So if you start at 100 Fahrenheit, it's going to get less and less and less as time goes on. Right? And other questions along the same lines before we do things a bit graphically. That's another problem. I did a mistake by writing stuff at the end. So example number 2. Again, that's a word problem. Okay. Here's the question. In a factory that produces laptop, the daily cost changes with the number of laptop produced. Makes sense. How much it costs really changes with how many you produce. Let F be the function that assigns to the number n of laptop produced per day the cost to produce n laptop. Okay. I give you a minute in case you guys are writing. I'm going to ask basically the same type of question I asked previously. So my question number 1 is, so you have a function, that's my machine. What do you give it and what does it give you? So what's the input and what's the output? Who would like to answer my question before save me picking a student and telling me that?
Sorry, could you repeat the question?
What is the input? It means, what are you inputting here? What do you think the output here? What does F do to you? What do you give it?
The numbers made, or it gives the laptops made a number.
Repeat. What do you give it?
You give F the number of laptops that were made that day.
Right,
F
the number of laptop.
Number to that laptop, right?
And what does it give you?
The cost.
Right, the cost to produce them. So the input is how many laptop you made per day, and what it spits out for you is the cost to produce them. So if I ask you now the following question, as like I did before. Suppose I give you the following information. Suppose I give you the following information. I tell you, okay, f of 1,000 equal 5,000. What am I talking about? What's the unit of 1,000? What's the unit of 5,000? What's the sentence mean? Tyler, do you think you can answer my question?
1,000 is the number of laptops made, and then 5,000 is the cost.
Absolutely. Write it in an English sentence.
Every 1,000 laptops made costs $5,000 to produce them.
Not every. If 1,000 laptops are produced, or basically the cost to produce 1,000 laptops, if you want. If 1,000 laptops are produced, the cost to produce them is $5,000. $5,000. So please, I want you to read always the function, understand it. Okay. Suppose now I ask you the following question. F of 2,000, is it bigger than 5,000 or less? So if I produce, okay, Tyler, stay with me.
It's more.
It's more because you're absolutely, of course, right? Because
You're making more laptops, so the price is going to go up.
it's not the price. Be careful. The output is what?
Oh, the cost.
Cost. The cost to produce it. Not, it's the cost to produce it. So if you produce 2,000, the cost to produce 2,000 is definitely going to be more than the cost to produce 5,000. Remember, the output is the cost. It's not the price per item. It's just how much it costs to produce 5,000. Okay, 2,000. So this is bigger because the cost to produce 2,000 is more than the cost to produce 1,000. Is more than the cost to produce 1,000. Okay, so as you produce more, your cost is more. That's right. So that's a rule. You give it how much you think you produce. So the companies sit down and start analyzing, you know, what they are doing. Okay, they say, if I produce 1,000, that's my cost. 2,000, that's the cost. So they have really to analyze the cost in terms of the number of laptops produced. Now, part 2 is, if I want to graph this function, okay, as if everything is rough sketch. So make a rough sketch of the graph and decide if it's increasing or decreasing. Make a rough sketch of the graph of this function and decide increasing or decreasing. Again, what should go on the horizontal axis? What should go on the horizontal? Let me pick one. And Tristan, are you with me? Okay.
Yes, I'm here.
All right. What goes on the horizontal axis? Remember how the function works?
It would be the number. It would be the number of laptops made.
Exactly, because that's the input. Number of laptop. Crucial. On the vertical axis.
It would be the cost of the number of laptops made.
Yeah.
So it'd be the 5,000.
Yeah. Not 5,000 only.
It could be the 1,000 too. I mean the.
It could be a lot of values.
Yeah, it could be, yeah, just the cost of it.
Right, it's yeah. So the number of laptop changes. You know, it doesn't have to be only 1,000, could be 2,000. And the output gives you the cost. So the company basically is going to make a chart. They want numbers. They want to say, okay, if I produce 1,000, that much. If I produce 1,000, that much. So how's the graph is going to look like? Increasing or decreasing?
It would be increasing.
Because as you produce more, your cost
The
is going
cost
to
will go up.
Right. So that's an increasing function. Okay. So F is increasing. So those are two word problems. The important for them is basic to remind you how to read a function, how to read this assignment. Now we're going to do two more examples, but they are more of a graphical nature. So I need one simple definition and then we take up the example. Okay, definition. Okay, suppose I tell you let f be a function and I tell you f is constant on the interval AB. What does this mean? Okay, so this is a function and this is an interval. This is an interval. What do you think I mean by saying f is constant on AB? Anybody can give me the definition? What does it you understand?
F is a number in between the intervals A and B.
F is a number. What do you mean by F is a number?
All I know is it's in between the intervals, whatever A and B would be.
Let me call this, here I put numbers like 2, 5. Okay. What do you think I mean by F is constant on the interval?
Oh, wait, F is constant. So does that mean it has to be in between those two intervals? It's one number between 2 and 5.
It's what?
Is it one number, like one constant number between 2 and 5?
Right. It means the output value is what? You're right. Is the output value? Go ahead.
Is it just horizontal?
Right, because the output value do not change. The output values are the same for every input between 2 and 5. Okay, so F constant means F doesn't change values. That's what F constant. What value is, I don't know, but it means that whatever the input is, the output is exactly the same. The output is exactly the same. That's what it means for a function to be constant. So the graph is a horizontal line. So if the output values are the same, so if the values that F takes is the same for all input that F of X take are the same for every X in the interval AB. For every X in AB. Regardless what X is, means regardless what my input is, my output is the same. So the graph is a horizontal line. So that's the graph is a horizontal line. Okay, that's what it means constant. The output is not really changing. It's the same, the same, the same, the same. Okay, now I'm gonna sketch a graph for you. And I'm gonna ask you basic questions about the graph. So it's a made up graph, nothing really deep about it. And so here's my graph. Let me draw it. I'll draw it with you because you're taking notes. You can draw the same thing. So this is my input here. I'm gonna call T the input value. And these are the output here. And that's how so the input are everything. I mean, my input is every real number is an input. So -1, because I put 2 here. And I'm gonna put like a 1 here. I'm gonna put a 2 here. And that's it. I'm gonna draw my function now. So for every input, I'm gonna give you an output. I'm gonna go like that. And then I'm gonna go all the way. So suppose this is my graph, this cute little picture here, and then my function go like this. Okay. So I did not give you scale on the y-axis because I don't really need it in this particular problem. So now here is the question. Determine the intervals over which f is increasing. Okay, this is my picture. Determine the interval over which f is increasing. So remember what it means to be increasing. It means when the input increase, the output increase. On which interval is the function increasing? What do you think I mean by this question?
From which 2 points does like the graph constantly go up and to the right?
Okay, so
Like at
up to the right. From where to where?
from 2 to infinity.
From 2 to infinity. Okay, it's increasing. Everywhere here. That's the interval. F is increasing. Not only at 2 or 3, everywhere. Because we don't say increasing at a point. It doesn't really make sense, increasing at one point. It increases on an interval. We have to let the input move to see whether the function is going up and down. Okay, so here f is increasing on this interval. Anywhere else is f increasing. Anybody else? Sandra, are you with me? Sandra, are you with me? Okay. Maya, are you with me?
Yes, I am.
Okay, where else is the function increasing? Look at the graph. It means the graph is rising.
I'm sorry, I couldn't hear you for a brief second. Can you repeat that?
Of course. Where else is the function increasing? So one of your classmates that is increasing for x bigger than 2 on this interval. Is there anywhere else where the function is increasing?
A little bit before -2.
-2?
No, in front of -2. I'm sorry.
So from where to where? Ooh, I'm sorry, you have kids.
So I would say -2, -1, and then going up.
Okay, so it means from -2 to -1?
Yes.
Is it only that? What about before -2? What's doing?
It's staying the same, but it's going up.
Is it increasing?
No.
Why not? Let me take a point here. So this is going down. And I move to the right. What's happening to the output? Are they getting, so that's the output here. That's the output here. Is the output still increasing?
Yes.
Because let us imagine, just for the sake, suppose this is -4 here. This is going to be -1. I mean, I'm just making up number. So the output, it's still increasing. It's negative, who cares? But it's still increasing. It went up from -4 all the way to -1. So my function is increasing, not from only -2. My function is increasing all the way till -1 on this whole interval. F is increasing. You see the difference? It's not only
yes, ma'am.
Everywhere. Very good. So now let's write this down. Let's write this down. And now I want to write it because I want you to see how we're going to write this. So we're going to write it in 2 ways. Okay? One, using interval notation, and one without it. So we know what we mean. So increasing for all values of x, such that x larger or equal to 2, I'm reflecting this piece, or x less or equal to -1. I'm reflecting this piece right there. Okay, so it's increasing for x larger than 2 or x less or equal to -1. Now in interval notation, it's increasing on the interval and on the interval. X bigger or equal to 2. In interval notation, I want to reflect this interval. Interval notation, this could be written from 2, everything above 2, infinity. Interval notation, x less than -1. It means -1 from -infinity to -1. This expresses the idea everything less than -1. So that's in word, that's in interval notation. Now, question number 2. Determine the interval over which f is decreasing. Okay, that's fine. Okay, who would like to answer this question?
Is it from -1 to 1?
It's from -1 to 1. The graph is falling. It means the output values are getting less. So the input is increasing. We're going to the right. -1, -0.5, 0, 1/2. But the output are getting less and less and less and less. So decreasing here. F is decreasing. So we write this down. F decreasing and or all values of x such that x between -1 and 1. So how do we write this? It means x is less than 1 and greater than -1. That's what it means. In interval notation is -1. So everywhere on this interval, -1, 1, the output is actually starting to decrease when the input is increasing. So finally, as you expect, the question is going to be, where is f constant? It means on which interval f does not change its value. Quickly.
1 and 2.
What do you mean 1 and 2?
Like it says constant, it does not increase nor decrease on.
I know. Yes, you're right. But what do you mean 1 and 2? Be more precise.
Those 2 points.
No, that's what I'm against for. Not those 2 points. Not only that. What about halfway between? 3/2. What about here? What about here? So it's not constant only at those 2 points because we have output.
Okay, so would it be just all the values between 1 and 2?
No, you're absolutely correct.
Okay.
Now you're correct. It's on this whole interval. It means you take any value, because there is not only an output at 1 and at 2, but there is an output at everything in between, because that's how the graph is showing. It's not bunch of points. It's just connected. It means everything between 1 and 2, it has an output, but it's the same. You see the difference between what you said and what I want you to say? Okay, so f is constant. All values of x such that x is between 1 and 2. Not only at 1 and 2, everything in between, or all over this interval it is. And what else? Or you can say, using interval notation, on the interval 1, 2. That's the interval notation. Okay. Okay, I think I have to stop because it's 1:44. 2 things. How is the Moodle coming up?
I had trouble getting back into it yesterday.
What?
For some reason, like up until yesterday, I kept trying to reset my password, but it said that I was on my math teachers from last semester's roster, so I couldn't get in. But yeah, I was able to actually get in and take it if I wanted to.
Okay, so anybody else? All right, for this time, because I want all of you to do it, I decided that I'm gonna give you an extension till Thursday at 11:59. Because I insist, I want all of you to do it, no question asked, okay? That's the only time I give an extension because, and it's only assignment 0. Some of you are doing assignment 1. No, I'm only giving you assignment 0. Don't do assignment 1. Do not do assignment 1, only do assignment 0, all right? So that's for Moodle. Second, you have a quiz next Thursday. So quiz 2 on Thursday.
This Thursday or next Thursday?
This Thursday, in 2 days. Okay, it's on the syllabus. I mean, but of course, you know, I told you. Usually the way I try to put it, the 2 lectures, then the third one you will have a quiz. So, all right, quiz 2 is on Thursday, and it will cover basically 1.6, 1.7, and what we did today. So please go over the practice problems and review them. Okay, so that's that. That's the Moodle. Make sure you finish it. And then what else I want to talk about? Okay, remember that you have an SI for the course. So to get help, you guys have opportunities. Come to my office hours. You don't, but now I'm encouraging you to come. Come to my office hours and also use the SI. You know, you have somebody, you know, Nelson, he's sitting with us, nice and quiet, but he have office hours. So please go to your SI office hours. If you cannot come to my office hours, use the help that is given to you. Do not just let go. Make sure you can follow every day. And anything else? No. So you have a quiz. Do the practice problem from 1.9. That shouldn't be hard. Make sure you finish your assignment. I gave you an extension. I won't give you an extension any other time, but this time, and it's only assignment 0. Don't do assignment 1. And please ask for help if you need it. Ask for help if you need it.
How many questions is assignment 0?
I forgot. Anybody did it? I think 7.
7.
7, yeah. Okay, and do not wait for the last time. You guys are waiting for the last minute to do everything. It doesn't work this way. You know, I gave you a week and I look up last night, a lot of you didn't do it. That's not the idea. The idea is that I gave you a week because, you know, to give you time to think about it, to ask me questions, ask the SI. Do not wait for the last minute. It's still the beginning of the course, so please start very well. Okay. Any other questions? I know that some students ask much about Moodle. You guys can stay. We can extend the hour. And anybody else has any